held in Las Vegas, a debate on the merits of intelligent design theory. Arguing for intelligent design, George Gilder, co-founder of the Discovery Institute, and Stephen Meyer, vice president of the Discovery Institute and editor of Darwinism, Design, and Public Education. Arguing against the theory, Michael Shermer, author of Why Darwin Matters, and Ronald Bailey, science correspondent for Reason magazine. The program is an hour.
I'm going to be arguing tonight for the idea that there is scientific evidence for intelligent design. But before I do that, it might be helpful to define what intelligent design is. Most of us have heard the conventional wisdom that intelligent design is simply religion masquerading as science. We've been told that intelligent design is warmed over creationism, that it's based on the Bible, that there's no scientific evidence in favor of it. But is this consensus view correct? Is intelligent design a religiously based idea, as we've heard from so many people in the media, or is there scientific evidence in favor of it? And what exactly is intelligent design? Well, perhaps the best way to explain what intelligent design is to contrast it with the idea it was specifically formulated to challenge. Richard Dawkins, the well-known zoologist from Oxford and sometimes public spokesman for modern evolutionary theory, modern Darwinism, has said that biology is the study of complicated things that give the appearance of having been designed for a purpose. And of course, the key word here for Dawkins and other modern Darwinists is the word appearance. For them, the appearance of design in living organisms is powerful but an illusion, produced by a purely undirected process, namely natural selection acting on random mutations, a process that mimics the powers of a designing intelligence, but which is not itself intelligent. Natural selection, in the words of Francisco Ayala, gives us design without a designer. Now, the theory of intelligent design takes the opposite view. Those of us who hold it think that there are certain telltale features of both living things and the universe that are best explained by an actual intelligence, not an undirected natural process, such as natural selection acting on random variation. Living things look designed because they really were designed. Now, in saying that, it's also important to understand what we are not saying. We are not necessarily challenging the idea of evolution, at least defined as change over time or common ancestry, two of the most common meanings of the term. But we are challenging the third meaning of the term, the specifically Darwinian idea that the cause of biological change is completely blind and undirected. There are basically two options when you're talking about how life got here. Either life arose as the result of a purely undirected process, or intelligence played some role. Advocates of the theory of intelligent design favor the latter option, and we favor that because, again, we think that things look designed because they really were designed. So that's the key issue. Is design real or merely apparent? Is it real or an illusion? We think design is real, and we also think that you can tell from the scientific evidence. Why do we say that? Well, we say that because there's been an extraordinary series of scientific discoveries over the last 50 years that have really altered the overall scientific worldview, or they should. In physics, for example, scientists have discovered that the laws and constants of physics are precisely fine-tuned to allow for the possibility of life. The speed of light, the expansion rate of the universe, the strength of gravitational attraction, and the strength of many other fundamental forces are balanced within very fine tolerances to allow for the possibility of life in the universe. This evidence has led many physicists to suspect that the universe itself is intelligently designed. Fred Hoyle, the famous British cosmologist, once said that a common sense interpretation of the evidence suggests that a super intellect has monkeyed with physics as well as chemistry and biology. I like this quote because it shows how the monkeys always make it into the origins theories, even in physics, even on the front cover of Michael Shermer's new book. But there's a second category of evidence for intelligent design that comes from microbiology and biochemistry, where scientists have discovered an exquisite realm of nanotechnology, little miniature circuits and machines, sliding clamps, turbines, rotary engines, and walking proteins, robotic-like walking proteins that tow around vesicles full of important materials on tracks and rails throughout the cell. Well, let's have a look at a couple examples, or at least one of these. We're probably all familiar, or many people may be familiar, with the bacterial flagellar motor, because Michael Behe has made this famous in his book, Darwin's Black Box. It's a little rotary engine that sits in the cell wall of a bacterium. This is not an engine designed by Mazda, but it has a rotor, a stator, a U-joint, a drive shaft, bushings, bearings, and a whip-like tail that functions just like a propeller. In addition, it's hardwired into a signal transduction circuit that gives the motor signals about where to propel the bacterium. I like to say it's high-tech in low life. This is a well-known example, so let me talk about another one tonight in a little more detail. This is a sketch of an exquisite molecular machine called an ATP synthase. This is a machine that scientists have discovered in the organelle called the mitochondria that's in every one of our cells. It's an energy-producing turbine that runs on the same principle as a hydroelectric dam. Instead of using a flow of water to drive the rotor inside the stator, it uses a flow of ions. Once that rotor begins to turn, it creates torque on the stem or the drive shaft, which in turn causes a conformational change in the proteins that are sitting at the top of that. That creates a little pocket that's just the right size for two molecules to nestle in, bind with each other, and form the molecule ATP, which is the battery pack, the energy-storing molecule in the cell. I have a chemical engineering PhD friend who has studied these. He says the efficiency of energy conversion and production in these is just absolutely mind-boggling, but it's all done on a miniaturized scale. Now, Michael Behe has made an argument for intelligent design based on nanotechnology, such as these examples I've just shown. And he argues that natural selection does not provide an adequate explanation for this type of system, but instead intelligent design provides a better explanation. His argument is well known, and it's not my argument for tonight, but if people would like to talk about it more in question time, I'd be happy to do so. I'm currently prepping a technical paper defending some of the Behe against some of the objections that have been made to his argument. Instead, though, I'd like to talk about an argument that's a little nearer and dearer to my heart, and that comes from a third category of evidence for intelligent design from the field of molecular biology. When I was still teaching college students, I used to ask them a question. If you want to give your computer a new function, what do you give it? What do you have to give it? And they, of course, would know. You need to give it software. You need to give it new lines of code. You need to give it machine code. Well, it turns out the same thing is true in biology. If you want to build a motor, like that rotary motor made of proteins that Michael Behe has made famous, you have to first have information for building the protein parts out of which the motor is made, which in turn requires sequencing smaller parts called amino acids in just the right way, so they fold and form these beautiful, intricate three-dimensional structures. But in order to arrange the amino acids correctly, you have to have instructions for so doing, and those instructions are stored on the DNA molecule. Now, in 1953, when Watson and Crick elucidated the structure of DNA, they made a startling discovery. The structure of DNA allows it to store digital information in the form of a 4-character digital code. Francis Crick later developed this idea with a hypothesis now famous called the sequence hypothesis. And according to the sequence hypothesis, DNA functions, the chemical constituents in DNA, the bases, function just like alphabetic characters or digital characters in a machine code or piece of software. That is to say that just as English letters may convey a particular message based on the arrangement of the characters, so too do certain sequences of the nucleotide bases in DNA convey instructions for producing proteins. The DNA molecule has the same property of sequence specificity or information content that characterizes all codes and languages. Now, what should we make of this? Well, at the very least, I think what we should recognize is that we have a very striking, a new and very striking appearance of design. Hubert Yockey, a famous information theorist who has applied information theory to molecular biology, has noted that the genetic code is constructed to confront and solve the problems of communication and recording by the same principles found in modern communication theory and computer science. Richard Dawkins himself has acknowledged that the machine code of the genes is uncannily computer-like. Bill Gates has added his observation that the DNA is like a software program, only much more complex than any we've ever written. So we have here clearly a striking appearance of design. But has this appearance been explained or explained away by any purely undirected process or any material cause? In fact, it has not. It turns out that the job of explaining the origin of the very first information is the job of scientists who are studying the origin of the first life. And that makes sense, because to build life in the first place, you need instructions to build the protein parts that make life possible. So the ultimate question in the debate about the origin of life is the question of the origin of biological information. It also turns out that the scientists who have been trying to explain that have come up against a dead end. And that, in fact, has been the case, an impasse of nearly now 50 years. This is not, I can say this without fear of contradiction, this happens to be my main field of interest, but this is also the consensus view among scientists who work on the origin of life problem. In fact, even last year, even Richard Dawkins last year acknowledged that no one has an adequate materialistic explanation for how life arose, and the key reason for that is what I call the DNA enigma, the inability to explain the origin of information from purely material causes. Now, is that the reason that those of us who favor intelligent design think that DNA points to design? Well, not entirely. It turns out there's more to the story. There's something else we know. We not only know that DNA and the information it contains has not been explained by material causes, but we also know something about what it takes to create or generate information. We know something about the cause of information based on our uniform experience, which is the basis of all scientific reasoning. This is a quote from Henry Quastler, a pioneering information theorist who applied information theory to molecular biology. And he made an observation based on our uniform and repeated experience. He said that the creation of new information is habitually associated with conscious activity. Now, is that correct? Well, of course, if we think about it, we realize it is. If you trace the information on a newspaper headline all the way back to its source, you don't just come to ink and paper, you finally come to a mind, to a writer. In the same way, if you trace a computer program back to its source, you come to a programmer, not just magnetized bits. And similarly, if you trace information in a hieroglyphic inscription back to the source, you come to a scribe, not just to a material process like wind and erosion. In fact, our uniform and repeated experience affirms that Quastler is right, that information always comes from an intelligent agent, not from an undirected material process. So when we find information in the DNA, the best explanation of that information is that it too had an intelligent source. Now, is this reasoning scientific? I think it is, and here's why. In the mid-'80s, I set off to go back to graduate school after having worked as a practicing scientist for a number of years. And I had become seized with this question of the origin of life and also the question of whether or not a scientifically rigorous argument for intelligent design could be made. And I began to study the works of the masters, of Darwin and his mentor, the great geologist Lyell, because they had pioneered a method of scientific investigation for studying the effects or the causes of events long past. And they had a principle that they insisted upon. If you're going to explain an event in the past, you need to know that the thing you're invoking has the power to produce that effect. And you need to know it based on your present experience. Lyell had his little dictum, the present is the key to the past, by which he meant that our present experience of cause and effect should guide our inferences about the past. And he had a memorable phrase that he used. He said that we should be looking for causes now in operation. Well, when I was thinking about this DNA, the issue of the origin of information, I suddenly asked myself the question, what is the cause now in operation that produces information? is there any cause that we know can produce information? And of course there is one, and only one, and that cause is intelligence. Now that becomes very important, first because it shows that the argument for DNA, from DNA to design, is an argument that uses a scientific method, in fact one pioneered by Darwin and his mentor Lyell. But it also shows that we're not arguing from ignorance. We're not just saying we think DNA was designed because these various chemical evolutionary theories have failed to explain the information in DNA. That would be an argument from ignorance. Instead, we're saying natural processes have not produced the effect of interest, namely information, but intelligent agency has and does. We see it all the time. Therefore, intelligent design stands as the best explanation for the origin of the information needed to produce life in the first place. So the basis for intelligent design is not religion, as the conventional wisdom has it. Instead, it's the discovery of molecular machinery, it's the discovery of digital information in the cell, and a complex information processing system for processing that information, and it's the discovery of the fine-tuning in physics, but it's also a scientific method, the method of inferring to the best explanation, using our knowledge of present cause and effect structure to determine which of the competing hypotheses is best. So not only is there scientific evidence for intelligent design, but the evidence that I've presented is based on a method of reasoning and a principle of reasoning that finds its origin in Darwin himself. So we have evidence for intelligent design, and indeed evidence that should be considered scientific. Thank you very much.
Steve, thank you. Now, taking the negative point, our first arguing in the negative, please welcome back a frequent speaker here at FreedomFest. He is the founding publisher of Skeptic magazine, a columnist for Scientific American. He lectures widely, produces television shows, writes books, including one of my favorites, Why People Believe Weird Things. And he may say scientific intelligent design is one of them. Please join me in welcoming Michael Shermer. Michael.
Thank you, Chip. Thank you, Chip. Thank you, everybody. I am Michael Shermer, the publisher of this, Skeptic magazine. We investigate claims of the paranormal, pseudoscience, fringe groups, and cultic claims of all kinds between science, junk science, voodoo science, pathological science, pseudoscience, non-science, and plain old nonsense. That's the commercial part. We've dealt with intelligent design for pretty much the whole existence of the magazine. It comes up very frequently because it's an important subject in American culture today. I used to call it pseudoscience. I think a more accurate description would be just non-science. In the sense that, well, there's a possibly apocryphal story of the great Wolfgang Pauli, the great Nobel physicist, who, upon hearing a colleague's or perhaps graduate student's lecture, was asked, you know, what did you think? And he said, it's not right. In fact, it's not even wrong. And that became sort of the definitive insult. But he didn't really mean it as an insult so much as it's not even wrong in the sense that we can't test it. And if it's not testable, if there's not some way to tell the difference between this hypothesis and that hypothesis, then it isn't science, because there's nothing more to do other than my opinion it is and your opinion it isn't, and that's sort of the end of the story. The subject itself has been huge throughout the last 100 years. The Scopes trial, in 1925, the Arkansas trial in 68, the Louisiana trial in 87 that went to the U.S. Supreme Court, and the Dover trial in 2006. All of them decided, including the Louisiana trial that went all the way to the U.S. Supreme Court, which they voted 7-2, determined that intelligent design, or creationism, or scientific creationism, or creation-science, it comes by different names, is not science. It isn't that it's masquerading as religion, or it's religion in a cheap tuxedo, or whatever the phrase is. That's irrelevant. Lots of scientists are religious. Religion has nothing to do with it. You either can test your hypotheses or you can't. It doesn't matter what your religion is. So that's the bottom line. And so in one sense, since we're here at FreedomFest, I should note parenthetically, one solution to the problem is if we just had private schools, the schools themselves can decide what to teach, and then it wouldn't be a public thing. But of course, that's not the world we live in at the moment, so of course taxpayers feel that they should have some say in what is being taught at public schools, and that's why we have these battles. So the question is then, what does become science? How does a particular new theory, like Stephen Meyer's theory, trickle down into high school biology textbooks, for example? One of my favorite examples of this that I write about in Why Darwin Matters, by the way, this is my first book that has on the cover full frontal nudity. That's one way to get past that, those sort of laws that worry about that sort of thing here, censorship laws. You make it a different primate. My favorite example here is Lynn Margulis. Lynn Margulis is a microbiologist who for 35, 40 years has been promoting her theory of the origins of complex cells, the sorts of cells you and I are made out of. These are called eukaryotic cells. Eukaryotic cells, you remember from high school biology, they have all those little organelles inside that you had to memorize, like mitochondria, for example. What Lynn noticed was that mitochondria have their own DNA. You've heard of mitochondrial DNA. It's how we trace lineages through the maternal line. Why would mitochondria have its own DNA when the cell itself already has a full set of DNA in the nucleus? Why would that be? Her answer is because mitochondria used to be its own independent, simpler cell, what's called a prokaryotic cell, the kinds of really simple cells that were the precursors to these more complex cells. So her theory, symbiogenesis, is that there was this sort of self-organized emergent property from simpler cells to more complex cells. Okay, the details don't matter. My point is this. It took her 35 years to get her theory out there and to be largely accepted by the scientific community. She did not do this by petitioning her congressman, by taking scientists to court to sue them, insisting that publishers publish her stuff because it's new or because people don't accept it. She just ground out the work through research, through published papers, monographs, textbooks, lectures, conferences, the way everybody else does it. So one answer to the question is, what do we do with intelligent design, is we don't have to do anything with it. It's up to them, just like any other scientist, to make the case and sell it to the rest of the scientific community. That's just the way it is. A slightly less controversial subject, a guy named Stephen Wolfram has this interesting controversial theory about how you can model all of science through these computer programs. He calls it a new kind of science. He published this massive book called A New Kind of Science. He's a brilliant guy, youngest to ever get a PhD at Caltech, and he's a multimillionaire from one of the most successful mathematical computer programs ever designed. Anyway, he's been trying for years to get his new kind of science to be picked up by other scientists. They largely haven't. Why? Not because he's religious or not or anything like that. It has to do with the fact that there's nothing to do with it. So far, no one's been able to figure out how to apply it in some useful way, because science isn't a thing. Science is a thing that you do. It's something you actually go out and do and test. And so that's the bottom line. So the question is, how could we do that? And here's the problem I see with intelligent design. That is, how do we know the difference between something that's designed naturally and something that's designed, let's say, supernaturally? Or from the top down by some intelligence versus from the bottom up by some natural forces. How could you tell the difference? Let's say we did discover that DNA was intelligently designed. Let's say we found some sign. Maybe there's a pod on the moon, and we discovered that in this pod, which was planted there by aliens, extraterrestrials, they left the blueprints of how they made DNA. They made it out of RNA, and they made the RNA out of the pre-RNA stuff, and so on. Let's say they have an actual blueprints. Now we've discovered, in fact, that those extraterrestrials are from the planet Vega. I say Vega because I'm pretty sure there was a Star Trek episode every other week where the aliens came from Vega. So let's say it turns out that that's true. DNA and life on Earth was seeded here by extraterrestrials from Vega. Okay, so intelligent design theory is correct. But that just begs another question. Where did those guys come from? How did they get to Vega? Did life evolve on Vega? Or was it seeded there by some other extraterrestrial from some other solar system in the galaxy? You see, at some point, you have to have some bottom-up natural forces to answer the question, where did life come from? Where did all this complexity come from in the first place? Positing something from the top down simply begs the question, yeah, interesting, but where did that come from, and where did that come from? At some point, to do science, you have to have some bottom-up forces that are at work here. A couple of principles before I address the specific points that Dr. Meyer made. before we say something is out of this world, let's first make sure that it's not in this world. That is, there is a difference between the known and the unknown, and there's a lot we don't know. So the fact that evolutionary biologists cannot explain all aspects of the natural world doesn't mean they're inexplicable. Or the forces we understand now can't explain it doesn't mean we haven't thought of everything. This leads us to a second point, the either-or fallacy or the law of the excluded middle. That is, even if it turns out that Darwinian evolution or neo-Darwinian evolution, or just forget the terms, some sort of natural evolutionary process, turns out that isn't the explanation. Turns out that's wrong. Even if that's the case, A is wrong, that doesn't make B right. B stands or falls by itself on its own evidence. It's irrelevant whether you knock down every little aspect of evolutionary theory. You still have this other problem. Yeah, okay, well maybe you're wrong too. Maybe it's C, D, E, and F theories we haven't thought of yet. So in other words, the thinking process of intelligent design goes like this. X looks designed. I can't think of how X was designed naturally. Therefore, X was designed supernaturally. That is, before you posit some top-down intelligence in there, are you sure you've thought of all the possible explanations for natural forces? We call it the God of the gaps argument. Whatever you want to call it, it isn't part of how we do science, unless there's some way to distinguish between an intelligence and a whatever you want to call it, a bottom-up versus a top-down process. And I think that's the problem. Dr. Myers made 3 points on the anthropic principle, bacterial flagellum, and the DNA digital information. So let me just say a couple words about each of those. These are 3 of these sort of gaps. These you guys haven't thought of really sound explanations yet, so this is where we think the intelligence came into play. Well, first of all, we do have half a dozen different interesting possible theories and hypotheses, explanations for why the universe came into being the way it did, what was there before this universe, how is it that universes are formed in the first place, perhaps out of the quantum foam fluctuation of a different universe that gave rise to our universe. Perhaps there's some underlying principle that underlines all these half a dozen to a dozen different interesting fine-tuned numbers. Maybe there's some number underneath all that, some single equation that can fit on a t-shirt. Boom, that's it. That explains all 12 of those numbers. We just don't know yet. We don't have a unified field theory that unifies global general relativity with quantum mechanics. We're a long ways from bringing all these forces together. So in other words, before we say, ooh, this is an unknown gap that you guys can't explain, we have to admit there's a lot we can't explain because we haven't tied those together yet. Science is only 400 years old. On the matter of the bacterial flagellum, well, this is a problem Darwin dealt with different subjects in his own time, called the problem of incipient stages. That is, I can see what good a full wing would be as an adaptive structure for flight and so forth. What good would half a wing be? 3/4 of a wing, 10% of a wing. How do you get from 0 to 1 with all the little stages in between when the little stages in between are not adaptive? How do you get there? Or the eye. What good is half an eye, you know? Well, turns out it's about half as good as a full eye. That is, having some vision is better than having no vision. And through that stepwise Darwinian process or gradualistic process, we can see how that works. But Darwin had a different answer. A phrase that was used by Stephen Jay Gould called exaptation. Darwin didn't use that phrase, but it doesn't matter. An exaptation is an ex-adaptation, a structure that had a different purpose originally from the one it has now. And the one it has now, we see in it, and you wonder, wow, it does this weird thing now. How did it get there back then to do that same thing now? And the answer is because it wasn't doing that thing then. So a wing, for example, was not a 10% of a wing, 50% of a wing, was not a poorly developed aerodynamic structure. It was a well-developed something else. That something else, probably a thermoregulator. Something to do with retaining body heat. As you flip the wings out, it releases heat faster. You hold the wings in, it holds the heat, and so on. There's a couple other theories about propulsion along the ground and so on. And so exaptation is one answer. And we see this with the bacterial flagellum. There's not the bacterial flagellum that needs an intelligent explanation. There's several different bacterial flagellums. Some are more complex than others. Some do 3 different things. Some do 2 different things. Some do one thing. Secretion or propulsion. Secretion, pumping fluids out of the cell. Propulsion, pushing it along, or clamping onto another cell or clamping onto the substrate. So you can have 3 different things, 2 different things, or just one thing. Turns out the older ones, the older, more primitive, simpler bacteria do one thing. The more newer, evolved, more complex ones do 2 things, and so on. You can see a stepwise, gradual process there. That's one possible explanation. And then finally, with the digitized information and DNA, well, I addressed that. Even if it turned out that DNA was intelligently designed from the top down, you still have to wonder, where did the designers come from? And here's my biggest beef with intelligent design. Since you're willing to grant that microevolutionary processes happen, you can't deny it, obviously, in bacteria and viruses and so on. You can watch them evolving, but that's microevolution. They're not becoming, cows or something. The question is, at what point do you think the intelligent designer, id, stepped in to do the process, to do the thing? Every million years? Every 10 million? Every other day? Every 2 minutes he steps in and does something? And of course there's no answer to that, because they have no answer to that, so there's no way to test that. And so those 3 points then again beg not for an intelligent top-down explanation, but again filling in those gaps with natural bottom-up explanations. Thank you.
Thank you, Michael. Next up, George Gilder, Editor-in-Chief of Gilder Technology Report, co-founder of the Discovery Institute, where he's a senior fellow. His most recent book, The Silicon Eye, was a finalist for the Royal Society's Aventis Prize for Science. Always a huge hit at Freedom Fest. Please join me in welcoming George Gilder. George.
Evidence for intelligent design. Well, we're here, aren't we? Here we are in Vegas discussing intelligence. And I believe that this really is the essential argument, that the entire universe seems to be contrived in exquisite detail and exhaustively intricate mechanism to produce ultimately us and allow us to contemplate the universe and arrive at theories about it. Now, I came to my skepticism about the prevailing views of Darwinism really from my study of economics. And when I began studying economics, my chief resistance was to the idea that not only that contemporary science not only rejects creation by some divinity, it rejects creation by human beings. Demand-side economic models leave no room for the entrepreneur, no room for the entrepreneur as a creator, as an inventor, as an imaginative source of new ideas and new things. It's the entrepreneur is completely subsumed in macroeconomic numbers that leave him as some kind of fungible function that could be performed better probably by a computer. But then I discovered Austrian economics, and boy, that looked a lot better. The Austrians actually had a role for the entrepreneur. But when I examined the Austrian argument more closely, they too were intimidated by this same materialist superstition that I saw in the demand-side economists. The entrepreneur was always governed by facts, material facts beyond himself. He was an opportunity scout. He was and arbitrageur, reconciling price differentials, rectifying disequilibria. And then now I discovered again that, hey, in Berkeley we've got Paul Romer. He's inventing a whole new model of economics that comes to terms with entrepreneurial creativity. And I examined Paul Romer's arguments, and he identifies the entrepreneur as an assembler, reassembler of chemical elements. And he says that the power of entrepreneurship is manifest in the huge variety of chemical elements that can be reassembled. What on earth could be less relevant to the role of the entrepreneur or to an understanding of entrepreneurial creativity than some concept of reassembling chemical elements? But this is the kind of nonsense that completely prevails in social science as well. It makes me think of as well as biology. It makes me think of the famous joke about the economist on a desert island solving his problem as assume a cruise ship. And this is the way economics really works. It assumes entrepreneurial creativity, wealth generation, but has no real concept of consciousness, imagination, invention that really does account for all economic growth. Well, these economists have nothing on the biologists. The biologists start with assume a universe. Assume a universe which is dense with all the carbon and nitrogen and oxygen and that is critical to the formation of life. Assume stars and supernovae that are disgorging the chemicals of life through the universe. Assume that these stars are located in precisely the right place to seed an Earth, a rocky planet with materials that might sustain life. Assume a universe, and then when you're on the Earth, assume that all the constants of physics are precisely tuned, as we've heard, but also all the constants of chemistry and the concepts in biology are all just perfectly tuned to, in the process of time, produce us. And you have to understand that all these phenomena represent virtual preparations for the manifestation of mind and creativity, the manifestation of science, the manifestation of technological creativity. All these things are implicit in the very formation of the universe. Now, the biologists say, when you confront them with the extreme improbability of all these compounded intricacies of labyrinthine complexity beyond imagination, they say, don't just assume a universe, assume infinite universes, multiple parallel universes. Assume that every electron in its Feynman path eventuates in a whole new universe. And that proposition is regarded by these skeptics as somehow more plausible than the existence of some power beyond us and beyond our comprehension. And as Richard Dawkins says, better many worlds than one God. Well, I disagree with Richard Dawkins.
Oh, George, I didn't see you heading for the landing quite so quickly. Yeah, I thought you might circle the airport once or twice first. Okay, good. We're getting close to being back on time. Our next and final presenter before we get to rebuttals Ronald Bailey is an award-winning columnist for Reason magazine, author of numerous things, including his latest book, Liberation Biology. I have to say, so far, everybody's convinced me. I don't know how you're doing, but I've agreed with everyone I've heard. Let's hear what happens with Ronald. Ron.
I'm delighted to be with you all, and I'm going to take the design inference seriously. You'll see how in a moment. Let me begin by first acknowledging the Discovery Institute website states, and we heard Steve Meyer say that something to the effect, but the website says, unlike creationism, the scientific theory of intelligent design is agnostic regarding the source of design and has no commitment to defending Genesis, the Bible, or any other sacred text. So far, so good. Now, I don't know, how many people saw the movie Expelled out there? Okay, a few of you all did. Near the end of that silly anti-evolution movie, Expelled, in which Steve Meyer appeared, the host, Ben Stein, asks Richard Dawkins, who is arguably the best-known living evolutionary biologist on the planet and a bête noire of the intelligent design movement, if he could think of any circumstances under which intelligent design might have occurred. Incautiously, Dawkins brings up the idea that aliens might have seeded life on Earth, which is so-called panspermia. This idea was suggested by biologists Francis Crick and Leslie Orgel back in the 1970s and was brought up, just as you see, by Mr. Shermer earlier. In the film, Stein acts like this is a great gotcha. You know, I've got him now. And he's miming, this is just the silliest thing I've ever heard. Of course, the irony is that this is precisely what proponents of intelligent design are claiming, that a higher intelligence has repeatedly created life on Earth, only they don't want that higher intelligence to be a race of purple space squids. So, since our esteemed opponents are agnostic with regard to the source of design, and because intelligent design cannot rule out the hypothesis that superintelligent purple space squids are not the source of design of life on Earth, I will provisionally accept the hypothesis for the remainder of my talk, that in fact life was created by superintelligent purple space squids. Now, as I understand it, intelligent design proponents, such as our esteemed panelists here, fully accept the fact that the Earth is around 4.5 billion years old and that some form of life has existed on Earth for about 3 billion or so years. If that is the case, it would seem that the record shows that the intelligent designers, the superintelligent purple space squids, evidently spent more than 2 billion years tinkering with single-cell algae and bacteria before they got around to creating multicellular species. So, a series of questions. Do intelligent design proponents have a theory to explain that? The laziness, if you will, of the superintelligent purple space squids. So, if so, how have they gone about testing their explanations for why this squid took 2 billion years to create multicellular organisms? In addition, the record clearly shows that when more complex forms of life were created by superintelligent purple space squids, they were apparently arranged in their creations in a very specific order. Why did the purple space squids arrange fossils in a sequence in which fish appear before amphibians, which appear before reptiles, which appear before mammals? And why did the purple space squids arrange 390 million years ago for the first amphibians to resemble crustacean fish, which were also alive at the time? These first amphibians had such characteristics as internal gills, fish-like skull bones. Interestingly, they also had 8 digits, such as those fish had. And apparently though, later on, our intelligent purple space squid creators, or whoever, found 8 digits somewhat displeasing and simply eliminated the extra 3 digits after they killed off the early amphibians and individually created thousands of later species of amphibians with only the now standard 5 digits. Interesting, the fossils of early reptiles, in which purple space aliens apparently created around 300 million years ago, were still rather amphibian-like in their overall structure. Legs were splayed out sideways, bellies were just barely lifted off the ground, tails dragging behind, a short salamander-like gait. Eventually, the creator aliens chose to produce tens of thousands of new reptile species, which differed considerably from the old sticks-in-the-mud amphibians. Among their creations were much grander reptiles, such as the impressively armor-plated Stegosaurus, 145 million years ago, the massive Apatosaurus, which was formerly known as the Brontosaurus, had been renamed, which measured 75 feet long and weighed 25 tons, and of course the largest land predator ever known, the 7-ton, 40-foot-long Tyrannosaurus rex, which was around 65 million years ago. So here's another puzzle. Why is it that the superintelligent purple space squid creators made the earliest mammals share so many characteristics with the therapsid reptiles, species that they lived among? Interesting, the researchers have now pieced together how the purple space squid created the mammalian inner ear, the thing that you're all listening to me with, I hope. Starting with the mammal-like reptile Phenacodon 270 million years ago, the purple space squid creators evidently spent the next 70 million years tinkering with the hinged reptilian jawbones, shrinking them, moving them back toward the ear holes and the skulls of some thousands of increasingly mammal-like species the space squids were busily individually creating in between time. Eventually, the purple space squid creators ended up, after 70 million years, making a tiny mammalian-type critter called Hadrocodium, which had a single jawbone, like all mammals do today, and having 3 middle ear bones, like all mammals do today, including you all. I am sure that the intelligent design proponents will shortly explain why apparently intelligent purple space squid creators, or whatever creators they prefer, use this pathway for creating inner ear bones. Since by definition, the purple space squids are intelligent and should know what they want in advance, or what ID proponents call complex specified information, why didn't they just create species with inner ear bones without creating creatures in the apparently slow intermediate steps? Which brings me to an even bigger puzzle. Why, after going to all the trouble of finally populating the Earth with millions of magnificent species, did their purple space squid creators, or whichever creators you would like again, apparently allow either a 5-mile-wide asteroid to hit the Earth, or a huge outbreak of volcanic eruptions, or both, to wipe out at least 50% of the species, including the dinosaurs living 65 million years ago? In fact, something worse occurred 250 million years ago when some event, possibly also another asteroid strike, destroyed 95% of all living species. Of course, there's an alternative hypothesis that intelligent design proponents, such as the distinguished representatives from the Discovery Institute on the panel here, might fruitfully want to explore. And that is that the purple space alien squid creators actually caused the asteroids to strike the Earth in order to wipe out the biological and ecological slate clean so they could start over. Perhaps like a thrifty artist who whites out an earlier painting on a masterpiece in order to create an earlier painting on a canvas in order to create a masterpiece, the purple space squids destroyed most of the life on Earth in order to make room for new creations. Interestingly, the creator squids seem subject to a strange kind of creative conservatism. Their new post-extinction event, individually created species, looked very much like the earlier created species that had apparently survived the massive extinction events. What hypothesis do intelligent design proponents offer to explain this interesting observation of creative conservatism? Apparently, purple space squids are progressive creationists. They bring species into existence over and over again, forming each species so that it bears a striking resemblance to species that have just gone extinct. Now, I've been using the phrase individually created species throughout my talk, probably ad nauseum, but why? Because intelligent design proponents, such as Steve and George here, insist that microevolution, which I take to mean, wait a minute, I get 12, which I take to mean any evolutionary change below the level of species cannot lead to macroevolution, which I take to mean evolutionary change at or above the level of species, which at least means the splitting of one species into two. Since microevolution, according to ID proponents like Steve and George, cannot lead to the creation of new species, then the purple space squid creators, or whoever, must create each species individually. Trying to figure out how intelligent space alien creators go about creating individual species would be a fascinating question for ID researchers to look into. Do the squid creators somehow tweak genes while the embryos are developing in their eggs or while they're in their mother's wombs? Or do they work at the level of sperm and eggs before conception? Would the space squid creators use radiation to do this, or chemical mutations, or errors in genetic transcription? What's their favorite method of producing new species? And most crucially, how would whatever processes purple space squid use to create tens of millions of new species over billions of years differ from the natural processes suggested by evolutionary biology? And there's yet another puzzle. Our conservative creators apparently recycle genes over and over again in new species. Biologists have found that many genes are like animal kingdom cassettes or Lego blocks. They can be mixed and matched across vastly different species. For example, biologists have shown that a gene crucial to building a fruit fly's eye, the PAX6 gene, will trigger eye development in a frog and a mouse. In addition, now that both human and mouse genomes have been sequenced, researchers know that 99% of mouse genes are similar to those found in humans, 99%. And even more amazingly, 96% of the genes in both mice and men are present in the same order on their different genomes, the same order. They're arranged the same way. Now, why would this be? A fascinating question for intelligent design researchers to answer is what constrains the superintelligent purple squid creators or other intelligent creators to use the same genes over and over again in millions of species. And here's a final curiosity. Why did the purple space squids design us humans so that we need to eat foods like oranges to provide us with vitamin C? Without vitamin C, people die of the deficiency disease scurvy. It turns out that the superintelligent squids created nearly all other mammals so that they have genes, including the GLO gene, that synthesize this vitamin in their livers. Biologists have discovered that when purple space squids created us, they, for some reason, left a remnant of the GLO gene in our genomes, but it's broken. But there's one group of mammals that share our lack of ability to make vitamin C. These include the orangutans, gorillas, chimpanzees, and macaques. They all too have broken GLO genes. Even more interestingly, biologists have found that gorillas and chimpanzees have exactly the same errors in their GLO genes that people do. So why did the purple space squids create those species along with us with exactly the same errors so that they and we cannot produce vitamin C? So one final consideration. Are the intelligent designers finished creating new species? Are they resting on their creative labors for now? What evidence would show that intelligent designers are still at work creating new species around us? And how would we know? I hear very little from the intelligent design proponents on how to answer those questions. The point is that of this disquisition is that intelligent design proponents do not have good answers to the questions I posed, but the evolutionary biologists have many fruitful answers to all of those questions. As Brown University biologist Ken Miller says, and I'm channeling him, I'm trying to anyway, he's probably much nicer than I am. Anyway, says, design rests ultimately on the claim of ignorance, upon the hope that science cannot show evolution to be capable of producing complex organs, assemblies of molecules, and novel biological information. If evolution cannot achieve that, the argument goes, then design must be the answer. It's the either or that Michael Shermer was talking about. Since any field of biology, including evolution, is filled with unsolved problems, intelligent design can be invoked as the default explanation for any of them. We don't know, so it's design. Finally, Miller correctly notes the hypothesis of design is compatible with any conceivable data, makes no testable predictions, and suggests no new avenues of research. Ultimately, the intelligence design hypothesis just leaves the creation of every species up to the whims of the moral equivalent of a race of superintelligent purple space squids or whoever else is the alleged source of design. Thank you very much.
Thank you, Ron. Dr. Skousen says it really is important that we have a question and answer period, and it's equally important that we end by 6:30 at the very latest. Therefore, for rebuttals, we're going to have to cut you back to 3 minutes. Sorry about that. And we're going to be strict about it. But let's begin with Steve. And you want to come back up here for your 3 minutes? Okay.
Be assured that we have many good answers to the questions that Ron just raised. There's not time to answer those, so I'm going to address the two big things that have been raised by both Ron and Michael. First, the claim that intelligent design is arguing either or. If Darwinian processes or chemical evolutionary processes can't explain something, then we are arguing therefore design, as if the negative, this is a formal argument from ignorance, is the claim, that evidence against something is therefore, we're treating that therefore as evidence for something else. We're not doing that. And the reason, what we are saying, is that there is positive evidence from our experience, from our uniform and repeated experience, that minds have certain capacities, and they leave certain signatures of their activity behind. One of those, and Michael asked for this, how do we tell if something's designed? Laid out in the Design Inference, Cambridge University Press book by William Dembski, a signature of intelligence is high specified information content, or what he calls specified complexity. I think we should make sure that, I want to stipulate, make sure we all noticed that neither Michael nor Ron even posited an answer to the question of the origin of biological information. Biological information is not an ancillary feature, like something about the ear bone of a particular species. Biological information runs the show in biology. If a theory of biological evolution does not have an explanation for the origin of information, it has failed a critical test. Now on to testability. The reason that Michael and Ron do not see evidence for intelligent design from all around us, we're saying that our powers as agents are amply demonstrated in repeated experience. We also see it in the lab in simulations. But they're assuming that to explain something, mind can't be an explanation, which is an odd position to take at a conference about free minds. Okay? Libertarian freedom depends upon top-down causation. We have the capacity to initiate new lines of cause and effect without being completely determined by anything before but our own intentions. Okay? That's one way of looking at what intelligent design is saying. That intelligent design is the idea that intelligent agents can choose to actualize outcomes. And they want to say that's not an explanation because they are materialists at bottom. Everything has to be a bottom-up causation. Now, on to testability. Michael and intelligent design have made two different predictions. I think you might be interested in this. According to the Darwinian theory, the information should arise, that is, after the first life, it should arise as the result of a random, higgledy-piggledy process of trial and error, natural selection acting on random variations. As a result of that, when the genome was discovered to contain many sections which did not code for proteins, Darwinists concluded that that meant the genome was junk, okay, that it was junk. Michael has a whole section in his recent book saying, look, why, if there's an intelligent designer, why is there all this non-coding DNA? Why is there all this junk DNA? Well, in fact, the theory of intelligent design predicted just the opposite, and predicts just the opposite, that in the non-coding regions there should be function, that the signal should dwarf the noise, if in fact the information in life was intelligently designed. Guess what? In the last 2 years, there have been an extraordinary number of scientific papers and experiments and discoveries showing that the non-coding regions of the DNA are non-protein coding regions, code for RNAs. They perform other functions. And the non-coding regions, the non-protein coding regions, function much like an operating system in a computer that directs the processing of the other information. And so the prediction that intelligent design makes has been borne out by future research. That means, first of all, that it makes discriminating predictions. Secondly, that it's testable, and that the predictions that our theory has made have proven true, where the predictions of Darwinism, the predictions Darwinism has made with respect to information have proven to be incorrect. So there's a lot more to say, but I'll stop there.
And now, with his 3 minutes, Michael Shermer. Michael.
Thanks. Are we having fun? So, Mr. Gilder, on your analogy between the economy and the ecology, as it were, I think you've got it precisely backwards, that traditional pre-Adam Smith economists and still many demand-side economists see the whole thing as still needing to be designed from the top down. That is the intelligent design argument. It is a top-down system has to be designed. The point that Adam Smith made with the invisible hand metaphor is the same point Charles Darwin made with the natural selection metaphor, is that there's a mechanism from the bottom up. It's just a bunch of organisms running around trying to make a living and get their genes into the next generation. And Smith's point was the economy is just a bunch of people running around trying to make a living, support their families, get their genes into the next generation. Out of that emerges the unintended consequences of this more complex economy at which we all get wealthier and so on. So I think the analogy is just the opposite. In terms of what Stephen was saying, I think I'll just cut to the chase here what I think is really going on here. That is, what's the real agenda here? I'll just, the elephant in the room sitting right there. Stephen Meyer's talked about Dembski, yeah, the couch, yeah. So Bill Dembski told the National Religious Broadcasters in February of 2000 that intelligent design opens the whole possibility of us being created in the image of a benevolent God. The job of apologetics is to clear the ground, to clear obstacles that prevent people from coming to the knowledge of Christ. And if there's anything that I think has blocked the growth of Christ as the free reign of the Spirit and people accepting the Scripture and Jesus Christ. It is the Darwinian naturalistic view. All right, this is a problem. If that's true, then we have a problem. It isn't true. The problem here is that Darwinian evolution, first of all, drop the name. This isn't a cult of personality. It's just whatever the natural forces are at work. We're used to thinking of Newtonian mechanics as bringing solar systems together, even though Newton in his own time, in his great work Principia, wrote, "This most beautiful system of the sun, planets, and comets can only proceed from the counsel and dominion of an intelligent and powerful being." He couldn't explain the problem of the plane, why the planets were all in the plane of the ecliptic, except for Pluto, but it's no longer a planet, so no problem. But nobody makes that argument. Dr. Meyer doesn't quote Newton saying, look, we need to have an intelligent designer explain the solar system. Why not? Because we have a perfectly good explanation for how the natural forces did it. My point is this. We have perfectly good explanations for this. Why can't we just assume that that's the way God did it? If you're a believer, just assume that God used gravity to form solar systems, God used evolution to create complex life. Thank you.
Thank you, Michael. Now, George Gilder.
I just came from Phoenix, where my daughter just gave a speech on her new book, which will be published by Knopf at the end of the year. It's called The Age of Entanglement. And I don't want to speak for my daughter, so this is my interpretation. But entanglement shows that quantum entities, once they've collided or originated in an atom, can go any distance across the universe, and you change a quantum entity of one and the quantum entity of the other, the quantum property of the other changes with no lapse of time. And this has been tested thousands of times. It's yielded the phenomenon often described as the quantum computer, which is a preoccupation of physics departments and engineers around the world. And a leading expert on the quantum computer is named Seth Lloyd. He's a physicist at MIT and a major figure who wrote a book called Programming the Universe, which I recommend you read, along with Michael Denton's Nature's Destiny, two great books on the destiny of the universe. And Seth would run screaming from the room if he were associated in any way with intelligent design. So I will not imply any such position. But his view in Programming the Universe is that the entire universe is a quantum computer operating beyond time and space through quantum entanglement, which unifies the whole cosmos, and in a single entity, pregnant and pervaded with intelligence. And it seems to me this is a scientist at MIT reaching a conclusion about the implications of his own physics. And he comes up with an idea that is really one God. And that seemed to me to be one unified universe full of intelligence, which generates the incredible plenitude of life that we find in our world. And I think that is another image of intelligent design. And intelligent design is present everywhere, and people who can't see it are really blind. They're blinded by a materialist superstition. They're like people in a two-dimensional world who are who tell people who come to them with stories of 3 dimensions that it's all, we've scrutinized these lines and there's nothing but natural selection and tautological survival of the fittest around here. Thank you.
Thank you, George. Stay up here because we're going to have some questions for you. Now, Ron, your final 3 minutes.
Just a couple of quick points here. I agree with I love the phrase that George just used, generates the plenitude of life. That's exactly what biological evolution has done. And I think that that's the way that if there is a creator, which I don't know anything about, that probably is the way he did it, and we have enormous amounts of evidence to show that, as a matter of fact. In any case, the anthropic principle, and I'm going to be stealing this idea from someone from Iowa State who was very critical of intelligent design. I can't remember his name, but I don't want you to think it's original to me, but I liked it very much, is the plumber's anthropic principle, we'll call it. That the Earth is perfectly situated close to the sun so that the lead would not melt, and therefore would be, and if it were too close to the sun, lead pipes would melt and the plumber would have no pipes to repair. If the Earth was too far from the sun, then it would be too cold and water would be frozen, and there would be no water to fill his pipes with. Thus, we can conclude that the Earth is perfectly situated for a plumber. That's the anthropic principle in a certain way. So the other thing, and I will just conclude with this on the notion of the origins of life. I don't think that's what we were debating here. What we were debating was, is there evidence for intelligent design? I don't think that the origin of life, this is where it goes, the origin of life problem is not solved. A lot of other problems have been solved, but to assume that this is the either-or logic of this debate is assuming that we don't know the answer to it, therefore design. That's the assumption that's going on here. Let's give science, it's only been around 400 years, let's give it another 50 years first. I think we'll find a lot between now and then before we jump on the design bandwagon. And finally, with regard to economics, there's no person I've revered more than George Gilder and his thinking about technology and economics. But I'm afraid that he's made a complete mistake with this one. Intelligent design is to evolutionary biology as socialism is to economic freedom. Thank you very much.
All right, I see you're already lined up for your questions. And a couple of rules. Number one, do ask a question. No speeches.
Oh, come on.
Yeah.
Come on.
If you would like to direct your question to one of the panel, please say so. As far as the panel goes, we'll give each side one chance to reply. That is, one affirmative, one negative, not all four, or we'll just get one question asked, knowing who's going to ask the first one. Let me call on Dr. Mark Skousen for our first opening question.
Great, thank you. Any of you can answer this. Maybe Michael Shermer, you seem to be pretty rational here. I'd like your reaction to the idea of breeding and grafting. If you look at today's world, you see the breeding, for example, of dogs. So you have an example of intelligent design and nature both working together. If you look at the history of the breeding of dogs, the Greyhound, the Doberman Pinscher, and so forth.
No speeches, Mark. No
grafting, I think this is a very important point. Or in grafting, take flowers, for example. You have artificial flowers being created, and you go out in nature and see flowers there. So it seems like there's plenty of examples in today's world of intelligent design and nature working together. A golf course would be another example. So why can't that have just existed forever, and you've had examples of both?
Mm-hmm. Yeah, in that sense, I think Darwin's metaphor, his opening metaphor of natural selection was just that there's these pigeon breeders and so on. That's artificial selection. Nature is doing something like that. Like all metaphors, it can be misleading. The invisible hand is in a way misleading because there's no hand invisibly directing anything in the economy. And the same in nature, there's nobody selecting anything. I used to talk to my young daughter about the polar bears as a nice example of a living transitional species between land and marine mammals. They're sort of halfway there, but that's not right because that implies that they're on their way to becoming marine mammals. You know, they're almost there, almost like they're sitting there on the ice floe thinking, ooh, if I could just get a little more blubber, a little more webbing between my paws, I'm there.
Worrying about global warming.
That's right. So, so I think
skeptics.
And so, fine, one last point, Mark, I think, because it's a great question. How does, then, these complex rises in information happen naturally? Well, I use the example of Lynn Margulis and the symbiotic collision of these simple prokaryotic cells into these more complex eukaryotic cells. Her book you want to read on this is called Acquiring Genomes. She has shown in the lab how organisms acquire other genomes and double, triple, quadruple their information content just like that.
Okay.
So that's how it happens naturally.
Steve?
Yeah, I think the question is very illustrative of an important principle, which is that ID and natural processes can work together. And the example you point out is very apt, because in the dog breeding pool, there is an enormous gene pool. There's an enormous amount of genetic information. But there's only so far, we know from breeding experience, only so far that you can push selective breeding. Eventually you end up with dogs like the British Bulldog with the short snout. If it gets any shorter, he starts to get occlusion difficulties. And every breed pushed to an extreme starts to end up with problems. What you're seeing there is the exhaustion of the supply of genetic information, where ID posits information is at the beginning, at the source. So we see natural processes using information over time, but you can't extrapolate from processes that are losing information over time to account for the big stepwise discontinuous jumps in information. And so for me personally, I think the origin of life is one of those things, but I'm also open to the possibility that things like the Cambrian explosion, the mammalian radiation, the big jumps in information that we see in the history of life are also places where information was infused into the history of life. Once that information is present, then it provides a storehouse of possible elaboration and variation, which is what we see in microevolutionary processes.
Can we call that an answer?
Sure.
Okay, good. To the gentleman in back.
Thank you. Spent a lot of time tonight talking about whether or not intelligent design is true or false. Sub-question that's very important is whether or not intelligent design is science. It's because it could be true or false, but it could also be a philosophical argument or a scientific argument. If it's science, then by definition, it's testable. So my question for the intelligent design proponents, what experiment would you do that would prove to your satisfaction that intelligent design is false?
Okay.
I like the question, but I want to reframe it a little. Science, the question of whether or not intelligent design is science is essentially a question of definition. It's not a question of truth. Is there evidence for intelligent design? What does the best evidence tell us? Is life the result of an undirected process or of an intelligence? That's a proposition that you can decide by evidence. The question of whether or not intelligent design is science depends on how you define science. Most people say that testability is part of science, and in fact, testability is part of the regime of the research program of intelligent design, which is to say it can be tested. Intelligent design can be tested in three interrelated ways. First of all, as I noted, when you're talking about inferring something about the distant past, the way you test an idea is by testing whether or not the thing you've posited is consistent with your knowledge of cause and effect. Our knowledge of cause and effect shows that only intelligence creates information. Therefore, when we posit an intelligent agent to explain the origin of the large infusion of information needed to create life, we're positing the only known cause which is consistent with our knowledge of cause and effect. Therefore, the theory has passed an important test. The second way that intelligent design is testable, like all other theories, including Darwin's theory, is by comparing the explanatory power of competitors with respect to that crucial notion of causal adequacy. And in the book that I'm writing now about DNA, called The Signature in the Cell, I make the case that intelligence is the only known cause which has the causal power to produce the effect in question, namely information. And therefore, it has superior explanatory power. Test number 2. Number 3, historical scientific theories don't necessarily predict what's going to happen under controlled laboratory experiments. Darwin's theory didn't make those kinds of predictions. But there are occasions when historical theories have implications about what we should see in nature, and those implications are different, or they are discriminating between two different theories. That's why I raised the point about junk DNA. Darwinism has a very specific idea about how information must have arisen. That idea entails the idea that there would be a lot of junk, a lot of non-coding, non-functional failed experiments stored up in the genome. ID looks at things differently, expecting that there would be the signal, that is, the functional information, would far exceed the noise. And that's exactly what has now been, what has now been determined by recent research on what the non-coding regions of DNA do. As I mentioned in my previous rebuttal, that information is now known to be functional, it's known to be informational, and it's known to function like an operating system which turns and directs and guides the expression of the information in the genetic program. Just like an operating system in a computer.
Can we call that an answer again?
Runs the computer program.
And Ron or Michael, either one of you...
deepens the case for ID.
Either one of you want to take a short rebuttal here? No. Okay, we'll go to another question in front.
I'd like to ask Messrs. Gilder and Meyer for their reaction to the judge's 300-page opinion ruling in the Dover case that intelligent design is not just non-scientific, but also willful deceit and outright fraud. This was a conservative Bush appointee. What is your reaction?
Well, my first reaction is that federal judges do not decide the question of what is science. That's above their pay grade. And libertarians, I think, understand that argument. That's a vexing issue in the philosophy of science. Philosophers of science have different arguments and ideas about what that is. But if you take the standard of testability as the standard of science, I've just shown that intelligent design is testable in 3 relevant and well-accepted ways within the conventions of scientific practice. So the judge's decision was wrong. Intelligent design does meet a crucial test of science, in fact, the one that's most commonly cited.
Okay, Ron, we haven't heard from you for a while. A word or two?
Well, I agree that it's above the judge's pay grade, but I wish the intelligent designers had not, in fact, brought the case to the court.
We did not bring the case.
No, I'm sorry. I'm sorry. You are correct. You decided you're going to try to force the schools to adopt your view.
No, that's incorrect. It's incorrect. That's absolutely incorrect.
I didn't say the Discovery Institute did, but certain people
well,
certainly
did.
Hey, come on, guys. What do you think this is? A debate? Hold it down.
No, that's just factually incorrect. I really need to correct that.
Okay.
What happened in Dover was a creationist school board wanted to advance their view. Most of the people on the board, we found out, didn't even know what the theory of intelligent design was. They then put some language into a resolution, and one of the board members stood up and defended it on the basis of an explicitly religious motivation. He wanted to get intelligent design into the schools for the sake of the crucified one. Well, the ACLU jumped on that because they understood the Lemon test. And when we looked at the case, we said we want nothing to do with this. Our science education policy is, in fact, that we want the strengths and weaknesses of Darwinian evolution taught. We have a textbook to do that. It's perfectly legal and constitutional. We're not trying to push intelligent design in the schools. We're trying to do what Michael said at the beginning of his remarks. We're trying to win the argument on scientific bases in peer-reviewed books, such as the one I held up before, and peer-reviewed articles. And that's the way we're proceeding.
Okay.
That was not our initiative.
And I didn't say the Discovery Institute, and yet Michael Behe.
Well, you said they were intelligent.
And Michael Behe, who is an intelligent designer, did in fact testify in that court.
That's right. We decided someone needed to defend the science.
Well,
I opted out. They asked me to be an expert witness.
So intelligent design was brought up.
Okay.
It was brought up, but it was not the initiative of intelligent design proponents.
Okay. This will be the last question. Go ahead.
You look at the design and you choose to call it intelligent. Why don't we call it nifty, nice, interesting, self-serving, useful, so that we avoid the question of designer?
You've made your point, and I don't know that we need to respond. Let's ask the gentleman in front if he has a question.
Actually, I think there's a serious answer to that, actually. That's a good question. The reason we don't call it nifty or clever or something else, we call it intelligent, or we refer to minds, because, remember, science is based on our experience of the world. And George keeps talking about the materialist superstition and how we're blind to something that's an important reality. The reality is our own minds, what our conscious deliberation can do. That's the basis of libertarian freedom. And the Darwinian worldview and the Darwinian theory says the mind plays no role in the history of life, the history of the universe. We know from experience that mind does play a role. And because of our own introspective awareness of what minds do, we choose to call our theory intelligent design because we know that minds are intelligent. We're talking about conscious rationality as the basis of the information that makes life tick.
Okay.
Why would an intelligent designer, in terms of the human body, put a waste disposal system right in the middle of a recreational area? That's what I want to know.
Whoa, no, sorry. We are running out of time. So there will be no more questions from the floor. I apologize, but we're out of time. Now,
I've never really had any complaints about that system.
Couple of things. First, some announcements. For those of you who didn't hear earlier what the plan is for dinner, cocktail party in the main room out there, 7:15. 8 o'clock, the doors at the far end will open to the grand ballroom and dinner will begin. Lost and found, we have a pair of glasses, roughly the color, frames the color of my shirt, and a little notebook in a bronze thing out at the place where the CDs and DVDs are. Now, finally, we want to find out what you thought. We didn't do a question at the beginning of the debate, but let's do it at the end. If you have your little blue paddles, if not, just hold up your hand. Which side do you think was the more convincing? Those who argued in favor of intelligent design, Steve and George, how many? How many? Oh, wow. Okay, back down. How many thought the anti-position, the negative position, Michael and Ron, carried the day? I'm going to claim victory by a small margin on the negatives. Yeah, no. You
can't count.
And with that, I want to thank our panel. A great debate. George, Michael has books outside. You can grab him and talk all you want. Michael Shermer will be signing books out at the table.
This event was part of FreedomFest 2008, a libertarian conference held annually in Las Vegas. For more information, visit freedomfest.com. Held in Las Vegas, a debate on the merits of intelligent design theory. Arguing for intelligent design, George Gilder, co-founder of the Discovery Institute, and Stephen Meyer, vice president of the Discovery Institute and editor of Darwinism, Design, and Public Education. Arguing against the theory, Michael Shermer, author of Why Darwin Matters, and Ronald Bailey, science correspondent for Reason magazine. The program is an hour.
I'm going to be arguing tonight for the idea that there is scientific evidence for intelligent design. But before I do that, it might be helpful to define what intelligent design is. Most of us have heard the conventional wisdom that intelligent design is simply religion masquerading as science. We've been told that intelligent design is warmed over creationism, that it's based on the Bible, that there's no scientific evidence in favor of it. But is this consensus view correct? Is intelligent design a religiously based idea, as we've heard from so many people in the media, or is there scientific evidence in favor of it? And what exactly is intelligent design? Well, perhaps the best way to explain what intelligent design is to contrast it with the idea it was specifically formulated to challenge. Richard Dawkins, the well-known zoologist from Oxford and sometimes public spokesman for modern evolutionary theory, modern Darwinism, has said that biology is the study of complicated things that give the appearance of having been designed for a purpose. And of course, the key word here for Dawkins and other modern Darwinists is the word appearance. For them, the appearance of design in living organisms is powerful but an illusion, produced by a purely intelligent design from the field of molecular biology. When I was still teaching college students, I used to ask them a question. When you, if you want to give your computer a new function, what do you give it? What do you have to give it? And they, of course, would know. You need to give it software. You need to give it new lines of code. You need to give it machine code. Well, it turns out the same thing is true in biology. If you want to build a motor, like that rotary motor made of proteins that Michael Behe has made famous, you have to first have information for building the protein parts out of which the motor is made, which in turn requires sequencing smaller parts called amino acids in just the right way, so they fold and form these beautiful, intricate, three-dimensional structures. But in order to arrange the amino acids correctly, you have to have instructions for so doing, and those instructions are stored on the DNA molecule. Now, in 1953, when Watson and Crick elucidated the structure of DNA, they made a startling discovery. The structure of DNA allows it to store digital information in the form of a 4-character digital code. Francis Crick later developed this idea with a hypothesis now famous called the sequence hypothesis. And according to the sequence hypothesis, DNA functions, the chemical constituents in DNA, the bases, function just like alphabetic characters or digital characters in a machine code or piece of software. That is to say that just as English letters may convey a particular message based on the arrangement of the characters, so too do certain sequences of the nucleotide bases in DNA convey instructions for producing proteins. The DNA molecule has the same property of sequence specificity or information content that characterizes all codes and language, basically fine-tuned to allow for the possibility of life. The speed of light, the expansion rate of the universe, the strength of gravitational attraction, and the strength of many other fundamental forces are balanced within very fine tolerances to allow for the possibility of life in the universe. This evidence has led many physicists to suspect that the universe itself is intelligently designed. Fred Hoyle, the famous British cosmologist, once said that a common sense interpretation of the evidence suggests that a super intellect has monkeyed with physics as well as chemistry and biology. I like this quote because it shows how the monkeys always make it into the origins theories, even in physics, even on the front cover of Michael Shermer's new book. But there's a second category of evidence for intelligent design that comes from microbiology and biochemistry, where scientists have discovered an exquisite realm of nanotechnology, little miniature circuits and machines, sliding clamps, turbines, rotary engines, and walking proteins, robotic-like walking proteins that tow around vesicles full of important materials on tracks and rails throughout the cell. Well, let's have a look at a couple examples, or at least one of these. We're probably all familiar, or many people may be familiar, with the bacterial flagellar motor, because Michael Behe has made this famous in his book, Darwin's Black Box. It's a little rotary engine that sits in the cell wall of a bacterium. This is not an engine designed by Mazda, but it has a rotor, a stator, a U-joint, a drive shaft, bushings, bearings, and a whip-like tail that functions just like a propeller. In addition, it's hardwired into a signal transduction circuit that gives the motor signals about where to propel the bacterium. I like to say it's high-tech in low life. Directed process, namely natural selection acting on random mutations, a process that mimics the powers of a designing intelligence, but which is not itself intelligent. Natural selection, in the words of Francisco Ayala, gives us design without a designer. Now, the theory of intelligent design takes the opposite view. Those of us who hold it think that there are certain telltale features of both living things and the universe that are best explained by an actual intelligence, not an undirected natural process, such as natural selection acting on random variation. Living things look designed because they really were designed. Now, in saying that, it's also important to understand what we are not saying. We are not necessarily challenging the idea of evolution, at least defined as change over time or common ancestry, two of the most common meanings of the term. But we are challenging the third meaning of the term, the specifically Darwinian idea that the cause of biological change is completely blind and undirected. There are basically two options when you're talking about how life got here. Either life arose as the result of a purely undirected process, or intelligence played some role. Advocates of the theory of intelligent design favor the latter option, and we favor that because, again, we think that things look designed because they really were designed. So that's the key issue. Is design real or merely apparent? Is it real or an illusion? We think design is real, and we also think that you can tell from the scientific evidence. Why do we say that? Well, we say that because there's been an extraordinary series of scientific discoveries over the last 50 years that have really altered the overall scientific worldview, or they should. In physics, for example, scientists have discovered that the laws and constants of physics are precise. This is a well-known example, so let me talk about another one tonight in a little more detail. This is a sketch of an exquisite molecular machine called an ATP synthase. This is a machine that scientists have discovered in the organelle called the mitochondria that's in every one of our cells. It's an energy-producing turbine that runs on the same principle as a hydroelectric dam. Instead of using a flow of water to drive the rotor inside the stator, it uses a flow of ions. Once that rotor begins to turn, it creates torque on the stem or the drive shaft, which in turn causes a conformational change in the proteins that are sitting at the top of that. That creates a little pocket that's just the right size for two molecules to nestle in, bind with each other, and form the molecule ATP, which is the battery pack, the energy-storing molecule in the cell. I have a chemical engineering PhD friend who studied these. He says the efficiency of energy conversion and production in these is just absolutely mind-boggling, but it's all done on a miniaturized scale. Now, Michael Behe has made an argument for intelligent design based on nanotechnology, such as these examples I've just shown. And he argues that natural selection does not provide an adequate explanation for this type of system, but instead intelligent design provides a better explanation. His argument is well known, and it's not my argument for tonight, but if people would like to talk about it more in question time, I'd be happy to do so. I'm currently prepping a technical paper defending some of the Behe against some of the objections that have been made to his argument. Instead, though, I'd like to talk about an argument that's a little nearer and dearer to my heart, and that comes from a third category of evidence for intelligence.